Hello, calculus students. This video is for chapter 4.5, part 1. We're trying to use derivatives to understand the shapes of a graph without actually graphing. The graphing calculator can tell us a lot about how the graph look like, but there's features of the graph that it doesn't tell us. And sometimes graphing calculator is not reliable because the zooming window, like the graphing window, is not, it's kind of, you have to know about the graph before you determine where you're looking at it. You can look at from negative infinity to infinity, so you might miss something. So it is important to know how to use analytical method or algebraic method to understand what is the shapes of the graph, some important properties of a graph. So there's 4 features that we should know about a graph. And intervals of increasing, intervals of decreasing. That means, like for example, I'm just going to randomly draw a graph. We want to know when it is going up. Okay, when it's going up. So this area when it is in the upward direction, that's increasing interval. We also want to know when it is going down. So this is the downside, right? Increasing, decreasing interval. When they say interval, is the interval of x. Local max and local min. We talk about those in 4.3, I guess, which is the point that is locally in the neighborhood is the highest point. So like this point, this point, this point, that it turns, the turning points. And then there's two new or 3 new terms that we introduce here, which is concave up and concave down interval. What is concave? Concave talks about how the shapes of the curve bend. Okay, so it could be increasing, but if it's facing downward, that's concave down. Okay, it could be. So this is concave down. Okay, CD. Concave up would be like this. Or even if the graph is increasing like this, that is still concave down up. So it's kind of like a bowl shape. The bowl is facing up, so it's concave up. Okay. Inflection point. What is inflection point? Inflection point. So actually there's a lot of example here. So this is a concave up, CD, CP. So it's like if you use your hand to hold it, it's kind of like holding a bowl up. And this is concave down, CD. So the band is facing down. Now, technically speaking, you can look at the slope of the curve. The slope is negative, right? Negative. Oh, and then it's positive, positive, very positive. So the slope is increasing. So it's a negative slope to become a positive slope. The values of the slope is increasing. Then we have concave up. Concave down is in the beginning I have a positive slope, but then it become negative. So the slope is decreasing. The slope become more and more negative. So that is called concave down in a nutshell. Increasing, decreasing. So this is increasing because when you draw a tangent line next to the area over here that's increasing, they're always facing up. Decreasing is when you draw a tangent line is down. Oh, and then we also have, local max and local min, the lowest point and the highest point. And then there's the last things is about inflection point. What is inflection point? Inflection point is a point in the last diagram where it is the place where before it was concave up. After it is concave down. So this is the place where there is a change in concavity. Or the other way around. You can have it this way. So in this particular area, this is concave down, and in this particular interval is concave up. At this point, there is a change of concavity, and we call this the inflection point. So this point is the inflection point. Okay, so let's just look at graph and identify them. Okay, so in this particular one, we want to identify, and remember, this is the graph of f of x. We want to see when it's increasing, decreasing, where's the local max and min. I think local max and min are very easy to do. Look at those top, right? So it is at 3.5, 3.5 is local max. I think there is another one like -2 maybe. X equal to this local mean. Oh, I don't know what the y value is. And x equal to 7.5. That's the local mean also. There's two local mean. What about increasing and decreasing? We just do a tangent line. Oh, this is increasing, not this one. This is increasing. This is increasing. So you just write the x interval. So from, let's say from negative infinity, or should I say negative 3? I don't know. Negative 3 to negative 2, that's increasing. Union, starting from increasing, let's say here, from 0 to 4 or 3.5. It's not very clear. 3.5, let's say. And then where is it increasing also? 7.5 to 8. Oh, this is looking like infinity. So this is increasing. What about decreasing? Decreasing when it is sloping down, right? So these two are decreasing. So it would be negative 2 to what is the stop? Negative 1. Union from here. This was negative 2, I think, all the way down to 7.5. So these are the intervals of increasing and decreasing. You use interval notation to write them. Then we have the graph of, this is a very funny graph. It is f prime of x. A prime of x. And we have to determine when it is increasing, decreasing, and concave up and concave down. Okay, so f prime, not f. So when do we have the graph being increasing? If we look at the original graph, when is it increasing? Increasing must be the derivative is positive. The slope is positive, right? So if this is the derivative already, when is f of prime positive? Everything that is above the axis f of prime is positive. And this, because it's an f of prime graph, this is f prime, not f. So this below it, f of prime is negative, right? So the increasing interval would be very easy. Only this part from 1 increasing, we will say from 1 to infinity. What about decreasing? All this below it, okay, all this below it. So it's at here, it stops. So we would just say from negative infinity to 0. And then at 0, maybe it's just constant, right? So we don't want to be included from 0 to 1. So all these are below the axis. What about concave up? Concave up is when look back at the picture. Concave up is when your slope was getting higher and higher. You have a increasing slope. Increasing slope means this graph, it has a increasing slope. It's increasing. So concave up is when you have 0, 1 to infinity. No, did I wrote this wrong? Increasing negative infinity to 1. No. Okay, it's this one. Negative infinity to 0. That's increasing those. That means you have concave up. Remember, this is not the graph. Is and then what else is increasing? From 0.5 all the way. That's also increasing, right? 0.5 all the way to infinity. That's also increasing. So that's all concave up. This part is going down, concave down. So when the slope is getting originally is positive and then getting a negative slope, that is when it is concave down. So it's from 0 to 0.5. Okay, remember this is f prime. So the next things we want to talk about is first derivative test. What is first derivative test used for? It's used to determine when you have interval of increasing, decreasing without graphing. Okay, without looking at the graph. If you look at the graph, of course you know when it's increasing, decreasing like this, right? I know this is increasing and I know, but without looking at it, can I analytically find out? So let's look at the step. The step is we use f prime because we know if it is increasing, the slope must be, the tangent line slope must be going up. So we find f prime, find all the critical points, and then do an interval, analyze the interval if it is positive or negative, and then draw the line. Draw the increasing and decreasing arrows. And how do I determine is it local max or local mean? You look at if it is going up to, like local max usually are like this, right? So you would have an increasing function on the left-hand side and decreasing function on the right-hand side. So that is local max. Local means usually are like this, right? So you have a negative, so this is positive to negative, from negative to positive slope. Okay, this one is local mean. So let's do this example, see if we can finish this example. Use first derivative test to find interval of increasing, decreasing, local max and mean for this without graphing. So use first derivative test. First derivative is very good at finding these four things: increasing, decreasing, and local max and mean. So how do I do it? I find all the critical points. F prime of x, do the derivative. 3x squared minus 6x minus 9, right? Critical point 0 equal to 3x squared minus 6x minus 9 factoring. 0 equal to 3 open parenthesis x squared minus 2x minus 3. And then you say 0 equal to 3 x minus 3. You can factor, right? Negative 3 and negative 2, it will be negative 3 and 1. And x plus 1. So what are the critical points? So critical points are x equal to 3 and x equal to negative 1. By solving f prime of x equal to 0. Oh gosh, I ran out of space. And then we would do I should use some space here. I would do a number line using this to divide the number line into subintervals, 3. And then I do testing. Test what? Test f prime. Okay. If you do f, you don't know whether it's increasing or decreasing, but f prime is the slope of the tangent line. It can tell you if it's increasing or decreasing. So first of all, I put x equal to negative 2 because I want to pick a point here. Then I look at this. Is equal to 3, which is positive, x minus 3, x plus 1, 3. If I plug in negative 2 is negative, negative is positive. And then I plug in x equal to 0, 3, 0 minus 1, 0 plus 1. This is negative, right? Negative, positive is negative. And then I test greater than 3, which is 4. Then I say 3, 4 minus 3, 4 plus 1. They're all positive. So now this is f prime sign. Then I'm going to draw f arrow up, up because it's increasing, down because it's decreasing. And then at this 2 point, this is the up because it's going up and down. So this is the maximum. This change direction like that. So that is the minimum. So I would say local max at negative 1 and then comma negative 1, local mean at 3 comma something. How do I know that number? You plug into decimal and you will find out. So let's see. What was it? X cubed, write it down. X cubed minus 3x squared minus 9x minus 1. Do I have enough time? X cubed equal to x cubed minus 3x squared minus 9x minus 1. And then I just need to have f of, what was it? F of the 2 point is 3 and negative 1. F of 3